can explain what you have seen there? Solar tree. Solar panel at the height. The size of the panel. The capacity of a panel. 7 kilowatt. At which voltage? So this panel is giving you the voltage. Voltage will depend upon how many you are connecting in series, how many panels. Each panel hopefully will have the near about 36 volt. Accordingly, how many panels, the voltage you can decide. At which voltage you want to work. And this we call the renewable. Why call the renewable? Source of electricity is not exhaust. So renewable, we are saying some new things by some other means. Except the conventional means, we are going some new means to generate the electricity. Conventional means was the thermal, normally natural gas, nuclear. So where you have a very big plants. Very big plants of thousands of megawatts. They are stored at one place, and then from there we are transmitting the energy to the load centers. How this energy is being transmitted? I think most of you are the electrical engineering. Do you understand the meaning of the grid? What is a grid? Anyone? Transmission of electricity from power station to the load. So it's a single power station or the multiple power station? The multiple power station. From this multiple power station to the multiple loads. So how the loads are receiving energy? Basically, loads are receiving energy from the wire network. At one point, you are drawing the energy. Like you are at the substation, then you are supplying to the locality. So as you already know, your voltage will work at the different levels. We generate the voltage, we transmit the voltage, we distribute the power, electrical power, and we consume the power. Like we have the electricity and we are at the extreme end of the electricity. So normally, till now, what we are doing, we are generating the power. You can consider the grid as a pool. In this pool, we are feeding the energy, and the loads are drawing the energy from this pool. So that is the wire network, and that we call the grid. In India, how many grids we have? Do you have any idea? So broadly, in the national level, initially we have the 5 grids. Northern grid, eastern grid, southern grid, western grid. And the northeast grid. So northern grid are basically supplying power to the northern area, which include the UP, Haryana, Delhi, Punjab. So they all will be supplied through this northern grid. Similarly, the southern grid will have one particular area, geographically. And then all the grids are there. Then what is felt that we have the excess of the power in the normally the eastern grid and the northeastern grid. A lot of power was generated there. And the consumer were there on the western side. If we go for the Maharashtra, Gujarat, a lot of industries were there, a lot of consumption was there. So, but if we have the independent grid, then it is very difficult to transmit the energy from, say, the eastern to the west area. So then the concept of the national grid will come. So almost everything now we can supply power from one end of the India to the another end. If we go abroad, so like in the Europe and the other, there you will find the international grids. We are from one country to another country, we are supplying the power. In India, neighboring of the India, like the Nepal and the other, Bhutan, there also we are exporting the power. So that all is basically working on a grid. So in that pool, we are feeding the energy and consumer and we are drawing this energy. In between, a lot of things are there. Naturally, we are generating most of the power was the coal in India. Due to the coal, a lot of carbon emission was there. So global warming, so many issues arises. Because of that, the concept of the renewable energy means how, without polluting the environment, how we can create the electrical power. Can we create? The first question was this. By using the natural resources. Say, my consumable resources like coal, gas, petrol, they all are limited in nature. But where you will have the access like the sun, the wind. These are the natural resources. They are never ending resources. They are always available. So then the research is started in this area. So we draw the electricity from the solar, draw the electricity from wind, which two major sources. Then we go for the bio waste, which is coming there in Diyalbagh, Agra. You will have all type of the resources except the wind, which are being utilized. Then comes the water, convert into hydrogen and then use it. So that will give a concept you can generate the electricity. But here, like you have seen in this field, the total capacity is here about 200 kilowatt. If that you have to generate the 200 megawatt, you can understand how much of the land and this is required. So in that case, it is thought about whether can we generate electricity in a small piece units and will consume. From here we got the idea of this microgrid. So by definition, if you will see, it is a controlled small scale power system consisting of the, so small scale power system, the number one. It will consist the small emerging generators. Emerging generator means the emerging sources. The loads, energy storage element, and the control unit that can be operated in the islanded mode or grid connected mode. So we have the two options. Whether this microgrid work in isolated way independently means like in your DI Agra, you have a lot of solar panels. And even you are not receiving electricity from the grid, still your system is working. So if you don't have any power from the grid and your system is still working, that is called your islanded. In addition, if you increase the load, so most of the resources we utilize here, and if the excess power is required, then power we will draw from the grid, from the main. So suppose we require 1,000 unit at one time, 800 we are generating here itself. So I require only the 200 to take. So by this, what we are doing, we are reducing the carbon footprint. We are reducing the carbon. Initially, we require the coal to generate 1,000 units. Now you require the coal to generate only the 200 units. So in that sense, basically we can control it. And whenever our load is less, we don't require the grid. We can utilize our power which is available to us to feed our system. So that will be my highlighted. So objective of the microgrid is improvement in the power supply reliability. So by now I'm not dependent on the grid system. So you also have seen in Agra, once if you don't have any, why you need generator in your, sorry, this inverter nowadays in your houses? Many of you will have, what is the reason? Because there is a power cut is there, so you can use the inverter with the battery, which can supply. That is give you the reliability of the power. So with these renewable sources, like in Diyalbagh, Agra, the reliability of the power is very high. Whether the grid is supplying or not, your major work is not effective. They keep on doing. You keep on doing. There is a sufficient backup with it. And most of the backup is in the form of the renewable form. So alleviate the environmental impact. We already have seen improvement in the stability and efficiency of the system. So efficiency is improved because the now power cut is reduced to a very low level. Ensure the diversity of the energy supply. Power supply can have reached to remote areas also. Say normally in normal case we have the grid accessibility. But in India itself, there are many areas where it is very difficult to connect the line. Although we are reaching most of the part. You can take the case of the hills, very remote villages. Suppose you require the 100 kilometer where the very small village is there. So means you have to basically lay the line of the 100 kilometers, where the population is hardly 1,000 persons. In that area, you can basically develop an indigenous power supply system, which will feed only to that route. So that will basically, you can access the remote area, you can supply electricity there at a very low cost. So the cost reduction in the electric card is also coming. That we said, I have the 100 units here, generated at any time, 200 I require from the outside. So the motivation behind such grids is due to the development of the renewable energy resources in a very fast pace. So within 10, 15 years, if I will compare the cost of this solar panel itself 15 years before, then the per unit cost was coming out to be the 15 to 20 rupees. In today's scenario, the solar per unit cost is hardly 2 to 3 rupees. So that is a development within the 15 years. The whole electricity development takes 120 years, but in the 15 years, the solar cost is reduced up to this way. Environmental concern it is addressed, which is a very lot of pressure. International pressures are on everyone. Development of the distributed energy resources. So previously, how we are using them? The question was where to basically connect these sources. We already have the grid. We have to supply. I have solar power with me. Where I will connect? Either I will connect the transmission side or distribution side or the load side. Everywhere you will have the different voltage. Like you have seen the solar you are generating at the DC. DC will be at any point. Can you utilize this DC directly? Very difficult. If you have to feed into the grid, first you require the converters. With the converter it is converting at what voltage? See, normally my transmission line is in the kilovolts. Your solar voltage is in the, normally DC is in, let's say the 360 volt. So once you have to basically integrate it with the grid, now again it's a very difficult task. So in addition to having the source, it was another question how to integrate these sources with the your working system where it can be utilized. This is the basic structure of a microgrid. The PCC which we are doing, we are saying this is the point of the common coupling. NB which is the given the medium voltage, that is my grid side. LV which is written, that is my low voltage side. And here we have the two portions. I have the fuel cell, diesel generator, synchronous generator, the synchronous symbol is given, photovoltaic, DGs, wind turbine, battery, flywheel. So these are basically the element of the microgrid. And as the PEI which is written here, PI is the power electronic interface. Like in your house, if there is no power, inverter is supplying the power. Whether the inverter is the source of energy. What is the source of energy in that case? The battery. Battery is the source of energy. So initially it is charging the battery. When there is no power, then this battery is supplying the electrical power. What is the inverter? Inverter is your PEI. That is the power electronic interface. This is the advantage of the power electronic interface. We are not especially saying it's the converter or inverter or what. So in whatever be your requirement, that you can convert. You having the DC, you can convert into the AC. You have the DC at a lower voltage, you can convert the DC at the higher voltage. That is the DC to DC converter. DC to AC converter. In case of the wind turbine, you will have the different frequency, variable frequency. Variable frequency to fixed frequency. So first we convert in the DC, DC will convert again in the fixed frequency AC. So that's why we say in all kind of the renewable sources, a very strong power electronics infrastructure is required. Like in Dayalbagh, you have seen many things. That's why we prefer this. You have the electric vehicles. Electric vehicle is there. Develop the electric vehicle nowadays is not a difficult task. But the question here is how to charge it. Do you require the charging stations installed in the Dayalbagh? That is your power electronic infrastructure. If I will think over the whole country level, so like you will have the petrol pumps every corner, in that way you require the charging station at every corner. Then only we can think of the electric vehicles. So with the renewable, we can say one of the major drawbacks, you always do require the power electronic interface. In any kind of this. So that's why normally in place of going to the transmission side, we are trying to integrate it on the distribution network, which is at the low voltage. Because the voltage which they are developing, that is not of the very high value. Or otherwise, to convert this again, you require a very large transformer, which will integrate it with the, say, 132 kV. How to integrate a solar power plant with 132 kV? It will be very difficult. You have the DC, convert DC to AC first, then AC to step up to that level, and then only you go for the integration. So that's why we say the renewable source integration with the grid is still a very big challenge. So when this CB, which is written here, is the point. This is the point of common coupling. When this switch is closed, then my grid is connected with this. When there is no power, so we can say that this is open. So the whole system is called the islanded system. My whole complete grid is working in the islanded mode. And here, if these two switches are basically connecting one grid to the another. So this we can say, suppose you have the excess power here, some low power here, you can supply power from one grid to the another grid also. And if you will see, this is nothing but the structure of a distribution system, where you are connecting these grids. That's fine. So challenges, costly installation, high payback period. Although this is written few years back, now the installation the cost is reducing, and similarly the payback period is also reduced. What you call the payback period? धीरे धीरे उसका कॉस्ट वापस आए. जैसे यहाँ पे if you will see, आप लोगों ने ये लगाया हुआ हम लोग 200 किलोवाट का सिस्टम. एक्सपेंडिचर इज नियर अबाउट, ये हमारा आईटी रुकी और दयालबाग का ज्वाइंट प्रोजेक्ट, हम लोग एक ही प्रोजेक्ट पे काम किए हैं. तो दिस साइड इज भगवान दास हैव इंस्टॉल्ड ऑल दिस थिंग. Near about cost, project cost is 2 crore. So what is the advantage? Now you are having the electricity without paying any money. So if you will see in how many times commercially I will install such a plant, it will not be too high. Let's say I have invested the 5 lakhs of rupees. So in how many times that cost will be recovered? It will become free. That is called with a payback period. That is my payback period. The shortage of the skilled hand. Nowadays, the skill development programs are running. Even if you are given the solar panels, you can buy it from the market. So how to generate energy? The experts are required for everything. The technical hands are required. So still they are in the development phase. Production and the operational issue. So we have a very strong production system in conventional power system, on transmission side as well as on the distribution side. In distribution side now we are adding the power. So distribution side is considered to be the power flow from one end to the another end. In transmission, power can flow in any direction. So due to induction of the renewable sources, what's happening in the distribution system, the reverse power flow can take place. So all production schemes has to be changed. And simultaneously, we will see here the different operational issue will also appear in this system. In other transmission system, like we have the standard voltage for the generators, transmission voltages, distribution voltages. In microgrid area, is still these standards are being developed. No fixed standard is available. Anybody can tell me what is the advantage of the standards? Why we develop the standards? Why standards are necessary? Like the standard for voltage, standard for frequency. Very good. So data dispatch means like you go in the market, you say the 60-watt bulb is required. So that is standard. You fit a bulb which is a 60-watt. So that is a particular standard is developed in the electricity. Whether it is your voltage consumption, you have the 230 volts, so every equipment will be the 230 volts. All equipment will be developed with the 50 Hz frequency. Their power rating may be different, but the few things has to be fixed everywhere. If you develop a bulb of the 110 volt to utilize for the 220 volt, that is a mismatch. So that's why such standards are required. In every area of the engineering, these standards are very much required. Low take up, left and the left payment mechanism, capacity building, requirement of serving companies, sustainable revenue. And so these are the challenges of renewable energy. And this is the scenario of the energy in India in up to 2020. This data is for 17, 12, 2020. Still now, the renewable has been increased. In this case, if you will see, major portion is still for my conventional source, which is the brown one. Green one is my green energy, which is the renewable, which is 24, and today's I will think it is 26 or 27. In the last 1 to 2 years, a lot of solar has been added. Some big plants has been added. And still it is increasing. So now it's a quite a major area is now coming from the renewable side. 24% of the total energy scenario is a quite big amount. And this is the case of the last, I think, 10 to 15 years. These are the few, the same representation. This is the state-wise representation of, I'm not able to read it, so you can go through there, they can read how much renewable that each state is generating in India. Any question?
So, what's the GWP and the solar potential?
Gigawatt. So microgrid benefits for utility, which are for the grid side, for consumer point of view, and for the government point of view. They are reducing the feeder congestion, ensuring power to the critical load, and the better demand and the supply management. From consumer point of view, better backup for the power, improve lifestyle, will as your 24-hour power is available. So naturally that directly we call about the lifestyle. Consumers are becoming prosumers. This is another very important point here. So they are using the electricity as well as the selling the electricity.
Solar panels, yes, buy or sell also means
That is basically on the government policy. Right, I have made a house. I have installed in my rooftop 5 kilowatt. So that 5 kilowatt I can use. How to use this power? There are two ways. One is I will convert this power into my home load and use this power. And the extra power I will draw from the grid. This is the one mode, but in this mode you require a very specific type of the converters. Now here again the role of the power electronics is very important. Second case which mostly is being used, you install the power and you feed this power to the grid. In that case you require a very grid feeding converter, which is very simple, very cheap. On the other side you go for the interlinking converter, that is very costly compared to this. In the grid feeding converter, they use a reverse metering. How much you are feeding into the grid and the power which you are taking from the grid. And the difference of these two, you have to pay. If this difference will become negative, if difference is positive, okay, I am the user, difference is positive, then I will pay to the supplier. What if the difference is negative? Means I use the less, but feed the more. Then basically government has to pay to the those who have installed this. But government don't do this. Say normally, okay, what is the difference that you have to pay? If it is going to be negative, we will not pay you anything. So prosumers means in most of the country, they are also paying to the consumer. In that sense, the consumer will become the prosumers. It will produce and consume both. There's a new word which appears 5 to 10 years before prosumer. Remote area consumer can benefit from the instant time of mind, like the we have discussed. From government point of view, the major advantage is that they are reducing the carbon footprint, which very long back our PM has basically give the assurance to the UN. India up to this will reduce up to this percent of the. That's why the load of expense is given to the solar. So because the new area developing, the job creation will be there, reduces the pupil migrations, will cause the better human development index. Challenges of the RE integration, we already have discussed a lot. So microgrid matrices, they are flexible, interactive, and compatible. Flexible in the sense they can work in with the grid mode. If grid is not there, then also they can work. If one inverter is gone, the other inverter can supply. They are flexible in this manner, interactive, operating in the isolated and the grid connected mode, compatible. So it is the most effective way to achieve the connection of the distributed energy. The energy which is going to be distributed in the throughout the area. Initially, we are concentrating the power plant at the one point. Like you will find, you will not find the power plant in everywhere. You have any power plant in Agra? The Agra is getting the power. So they are basically, it will depend upon the area which are rich in the coal. So plants are nearby to this. Otherwise, the transportation cost will increase. Like the Shakti Nagar area here in UP, Alpara, this area you have very big power plants.
The nuclear plants is that's from GD.
Nuclear power plant is one of the way by which you can have the longer time for the power. But due to the few accidents all over the world, they are not being preferred too much. But still, you are right, the nuclear power plant is one of the replacement of the coal, which you can get. But again, you cannot place it at everywhere. Like we have seen, it is a very small percentage of the nuclear you will have. Because a very specific type of the environment as well as the construction is required in the nuclear power plant. So, like we said, what is the architecture of a microgrid? As we have seen, our most of the generation is in the DC form. If I will take the fuel cell, generating output is DC. Solar output is DC. Wind output is AC, but of the variable frequency. Bio is, we can have the generators have the pure AC, can work like it is. But our most of the loads are the AC in nature. In the AC microgrid, my bus is the AC bus, and all type of the energy I'm converting into the AC and connecting it to this line. So that is my AC microgrid. Another is my DC microgrid, because my most of the generation is DC in nature. So now you can have all lightning, fan, other things. If I will basically connect in the DC form. The advantage here is, here I'm using the conversion from DC to AC, which is reducing the efficiency of my system. And that can be improved in case of the DC. So in place of having the AC bus, I will have the DC bus. And most of the load, I can convert into the DC. Like nowadays, we will have the ACs. Get the inverter type is. What is the meaning of this? Anyway. Inverter AC use करते हैं ना? Very popular in the ad you will see. You will see the inverter AC. What is this?
But they have very less drag load.
Okay, that's specifically show you how it works. Why we call it the inverter AC?
But it's work on a DC. Kind of the solar AC जो आ रहे हैं आजकल, particularly that is basically work on the DC current.
In normal AC also basically which you we say it will reduce the power consumption to a very low level. There we use the inverter, converting DC to AC. In case of the AC, my compressor is of the AC. AC compressor is there. How we get the best motor control? For AC motor. DC motor control पढ़ा है? Speed control हो गया AC. Induction mode. V by F control. Voltage and the frequency control. So by this, if I can make my frequency variable, so V by F I can control. So what we are doing, we are connecting the AC, converting into the DC. DC, again we are using the inverter, converting into the AC. So what was happening before? You are directly driving the compressor with the AC. When the temperature is there, it will cut down. And then it will, again it will start. So as you know, in starting, it will draw a very large current. It is consuming a lot of power. With this, what you are doing, you are reducing the speed V by F. So F you have to decrease. The voltage you have to decrease. So you will have the V by F drive in that case, which is basically driven by the DC voltage. So the one form of the efficiency, you can increase further the efficiency of your AC. DC is required, DC is available to me. I convert this up to that level. And further you will place this V by F controller. So that is the inverter AC, which is basically giving it, mainly is used to reduce the power consumption. So that advantage directly I can have with the AC. So power consumption, so that's why we say that DC will be more efficient. But say solar directly giving me the DC, even in where we are using the wind, we are first converting into the DC, then again converting into the AC and then feeding to the grid. But most of our load, once we will go for the industry, big industry, they all are using the induction motor. And induction motor cannot be replaced by the DC. Because it's very cheap, its efficiency is quite good, maintenance is very low, it's currently motor if you are using. So the solution here is you can have the hybrid. You will have the DC as well as the AC. You can have most of the load the DC in nature, which are directly feeding. So I have the two bus. One is the DC bus, other is the AC bus. AC load is connected to AC, DC load is connected to DC. And in between, I can have an interlinking converter. If my DC load is more, I can draw power from the AC side. If my AC load is more, I can draw power from the DC side. So that was the basically concept of our project, which is installed here. If I don't know whether you have visited or not, you have seen the most of the lightning is there by the DC. With the redox flow battery is installed. And simultaneously you will have the AC power also. So AC and DC power you can utilize, and in between you can interlinking converter which can supply power in the motor. So that is the structure of my microgrid. Here are the few merits and the demerits. I will leave the slides here, you can study. And we said my grid can operate in the two mode, the grid connected mode and the islanded mode. In between, if you have any question, you feel free to discuss. So microgrid connected with the utility grid with the point of common coupling. So in case of the grid connected mode, the advantage here is the most of the control is done by the grid itself. We have a very effective grid system well-developed grid system. So whenever can you tell me what is the meaning of the frequency control? Anyone? Okay, what happens if I will switch on the AC and switch off the AC? What practically is happening in the system?
So suddenly the voltage,
Sudden
raise the voltage.
voltage, sudden drop in the voltage. Voltage is fixed, 230 volt.
Ampere.
It will draw the current. What is the effect of this? What is the effect upon frequency? Have you done the experiments, machine lab? Is that big year? Which year you are? Second year. इलेक्ट्रिकल मशीन लैब किया, डीसी मशीन एसी मशीन सब किया हो। डीसी जनरेटर पे जब हम लैंप लोड जलाते हैं, व्हाट हैपेंस टू द स्पीड? स्पीड तक पे क्या फर्क पड़ता है? स्पीड कम होगी, ज्यादा होगी, क्या होगा? नेचुरली आप चल रहे हैं, आपके ऊपर 10 किलो वजन और रख दिया जाए, व्हाट विल हैपन? Will you move at the same speed? Your speed will fall down and you have to move with the same speed. What to do? Generate more internal power.
Yes, sir.
Define. So for all generators, here is a prime mover. What is prime mover?
There is the shaft of the generator to start the energy production.
Right. Say for any generator, you require the rotation. So all generator, what is the generating principle? Second year. What is the principle of the generation? Oh, you know, everybody knows. Faraday's law of electromagnetic induction. पढ़ा है ना? क्या होता है? Anyone? What is the Faraday's law of electromagnetic induction? When the flux linking to any conductor will change, it induces voltage. In all kind of the generation, this is the basic principle which is followed. Whether it is AC, whether it is DC, or what. So my objective is, even in the transformer, what is the electrical flux which is linking to generator will change. Linking to the conductor. So what happens with, if I have a DC, flux cannot change. So what we are doing, we are giving a rotation. So that's why you require a rotor. The rotor is rotating. Rotor पे armature रहता है in case of the DC. In case in AC machine, what is there? In synchronous machine, it is the field again, which is DC nature. So in both the cases, by giving, you require the movement of this. So the flux linking will change. And then it will generate the electricity. So like a generator is converting one form of the power into the electrical power. The form of the power is mechanical in nature. So if I am saying the, and what is the frequency, relation between the frequency and the speed? One 20 F by 3. Very good. क्या होता है? That is the synchronous speed. N is 120 F by P. So your frequency is directly related to this speed. If the speed will fall down, what will happen? The frequency will fall down. So always the increase in the real power are measured by the drop in frequency. Here, very randomly you switch on the electrical load. But this power is coming from the grid. It's very minute, but it is going to affect it. In larger wave, suppose what we say, the peak load means what? Suddenly, it's a very summer of the June. Timing is 1 p.m. or say the 11 to 4 p.m. Heat is at the peak. तो नेचुरली जितने भी एसी होंगे सब चालू हो जाएंगे और सारे एसी चालू होते हैं सिस्टम पे क्या फर्क पड़ेगा frequency will fall down automatically because you are using the real power and this power is coming from the generator. You can increase the frequency by increasing the power which is going feed into the generator. If it's a thermal generator, so you require the more steam to pass. So in addition to this, there is another thing is connected called the automatic generation control. In normal grid, there are two things. One is, like the previously said, voltage and the frequency. There are two very important parameters which changes rapidly due to the load. And load may be of active in nature and reactive in nature. Normally, due to the reactive power, your voltage will drop. Real power also voltage drop, but major source is the reactive power. Suppose here you will have a generator. Is it fine? The discussion is okay. I think in place of I will read the slide. Okay, basically main concept is comes from this. I have a generator, a transmission line, and the load is connected. Very simple. Okay, to all final year and tech students. Second year can also answer. What is the transmission line will have? What are the major component of the transmission line? Resistance and inductance. That's fine. Even my load. Here is a generator, let's say the thermal power. I am increasing the load. What the effect will come? Load increasing means the more current will flow. Load flow the more current. So my line current will increase. If my sending at voltage is V1, sending out another voltage is a V2. V1 is coming from the machine. So V1 is fixed. What is the effect on the V2? V2 is V1 minus this drop. If the current will increase, the line drop will increase. If the line drop is increased, so what will happen? The voltage will decrease. Normally in a big transmission line, major portion is inductance. What is the IXL? This is the reactive power. So the reactive power is the major source of your, even your load is the real power, drawing the real power, which is supplied by generator. Even then, there is the reactive power change, reactive power draw, which is appearing in the system, which is the major cause of the voltage. And major cause of the drop in frequency is the real power. So these two things we have to control at the generating stage. So if you have been studied, I don't know whether you have studied or not, You have the automatic voltage control loop and automatic frequency control loop. The voltage control loop and the frequency control. APR and NFC. Low frequency control and automatic voltage regulator. By this, we control the active and the reactive power of the generation to control the frequency. In case of the microgrid, what will happen? So this we have to see how to control the frequency and the voltage. Because here I don't have any rotating machine. We have, this is the basically capability of the synchronous generator, which we are using. It can supply the real power. It can also supply the reactive power. And these all experiments you will perform in your laboratory. How to use it. How many final year students are here? Third year, final year. Machines पढ़ा है, electrical machines. Vehicle पढ़ा है. Generator का vehicle draw करते हैं एक experiment. That is the your generator phase angle is lagging or leading. That will basically decide the capability of your generator to supply the real power and the reactive power. If you have not studied, later you will study this. So now another thing comes the modeling. Anybody can define what is the meaning of the modeling? Mathematical modeling. Any physical system for study, we normally write down the mathematical equation. The representation of a physical system in mathematical equation, either in the normal equation, algebraic equation, or the differential equation. If it is the differential equation, then we call the dynamical model. If it is in the algebraic equation, we call it the static model. Right? Armature control DC motor. कंट्रोल सिस्टम पढ़ा है आप लोगों ने, कोर्स पढ़ा होगा. आर्मेचर कंट्रोल ट्रांसफर फंक्शन क्या होता है? आर्मेचर कंट्रोल डीसी मोटर का ट्रांसफर फंक्शन निकाला है. इसमें इंडक्टेंस भी कंसीडर, कुछ नहीं. एक मोटर पे हमारे पास इंडक्टेंस होता है, रेजिस्टेंस है, मोटर है, बैक ईएमएफ है, KVL and KCL I have to implement. All mathematical models are developed using the KVL and KCL, which everybody knows. अगर मैं इंडक्टेंस लूंगा तो मेरी इक्वेशन हो जाएगी डिफरेंशियल इन नेचर. अगर आप you will neglect the inductance, like in a DC machine course, you write the equation V equal to E plus IR. In control, we write the equation V equal to E is the back EMF plus IR plus L di by dt. So di by dt is there, so the differential equation. So the differential, it is a dynamic model. So we can have the transient analysis. If I have the static model, I have the steady state analysis. All differential equation or dynamic model finally can be converted into the static model. So similarly, to analyze a microgrid, we require the mathematical modeling of each and every component. My first is the solar. Very famous model is used here. That is a single diode, current source with a single diode and two resistors. that I can represent a solar cell. Where here I will get the voltage. So whenever the light falls, the photon will change and they will generate a voltage V, which can be expressed by this equation. I'm not reading the equation or giving any derivation of the equation. Okay, this is a very simple standard. That is a solar cell and that is a solar panel. So what is a solar panel? It is nothing but the collection of a number of solar cells. These solar cells I can connect in the series or I can connect in the parallel. So based on this, I will develop a solar panel. So you can say the only one portion. This is the one solar panel. Okay. Based on this, we will have a solar panel with a standard voltage. Like say the 36 volt. So a number of solar cells are connected in series and parallel. But one panel is giving me the 1 voltage. Now, these panels now can further be combined to generate some higher voltage and the higher capacity. One single panel is, let's say, is of the 100 volt. I have to generate the 500 volt. I require the 5 panels. I will require some specific voltage. So that voltage by the series and the panel connection, I can generate. That complete will give you the solar panel. I have a solar cell, then I have a solar panel. Then with solar panel, I can generate my one module. Like you have seen in that field. With the one big structure, with a number of the solar panels are connected. And combinedly, they are giving the linear load 11 kilowatt. I think the 360 volt is there. Total 360 volt. So they are connected in series and parallel, that adjustment we can do. That is in our hand. Now with this, we will have the converter. This is called DC-DC converter. What's happening here? I am getting the voltage from the solar panel. Okay, this converter is simple DC to DC converter, which is giving you a DC voltage here. But what happened? Like your solar radiation will change. So your basically DC voltage will change. Your objective is to keep this output voltage, this voltage constant. Voltage which is coming at this inverter point. This voltage remain constant throughout the day. So this DC-DC chopper is nothing but keeping this voltage to be constant. Second, it is also serving the purpose of your MPP, maximum power point tracking. So later we will see what is the meaning of this. So now if I will connect this, then connect the inverter. So this is the basic equation for the solar cell. Now with this, using simple KV and KCL, I can write this mathematical equation for this system. So initially this cell system will convert into the 4-state model. Those who have understand the control system, they can understand. So this we are representing in the form of AX plus BU, Y equal to CX plus DU. So it will convert into the 4-state block. This is the wind generator, and these are the equation by which we can represent our wind turbines, wind system. This is for the battery model. Here we are connecting the batteries. This is another parallel RC battery model, which is again a 4-state model. because you are not, have not studied, so I'm just guessing. The interesting part I will skip. Okay.
Okay.
But it must be, this is a single solar source with battery module, which goes up to the 7-state model. Purpose here is, as we keep on integrating the devices, the order of the system keep on increasing. A very simple 2-state model will comes out to be up to the 14-state. So in this, once you are working in with such a model, so you have to work the very large state models. So not only, that is from research point of view, I'm saying, so not only the direct model to be solved, the other technique like the model reduction and the other can also be utilized. So that is the 14-state, all equations are here. Time domain, frequency domain analysis, that's I will. This is keeping. So once you have a x dot equal to x plus bu, y equal to ch plus du, so you have the model with you. You can have the model plot, frequency analysis, time response analysis. If you give the step input, what will be the output? That all analysis can be done. That is required. We have to basically analyze the system from stability point of view. What is the eigenvalue structure? Where the eigenvalues are placed, whether my system will be stable or unstable. Then all analysis help me to develop the controller for such systems. Fine. So now, how to plan a microgrid? You are given a task. Okay, you take a village, develop microgrid for that village. What you will do?
देखना पड़ेगा उस कंडीशन में कौन सा जो है उसका आउटकम देखना पड़ेगा वहाँ पे विंड एनर्जी सफिशिएंट होगी तो विंड एनर्जी लगाएंगे सोलर
कितने लोग?
कितना वहाँ का क्या कहते हैं
आगे
टमाटर
कौन कह रहे सोलर लगाओगे? So in any region, we will have the forecasting. So first of all, we have to forecast the load. Load is not a fixed quantity, load is a variable quantity. So we have to basically check the load cycle. Have you ever seen the load cycle for the complete year? If you start from the January 1st to December 30th, so that will depend upon the location, what type of the environment is there, what type of the equipment to be used. It's very cold, then the heating will be required. It's a normal season, no fan, no, nothing is required. So naturally, so your load curve is a very volatile thing. And whenever we are going to plan it, we plan it for the peak. So we have to first of all select the load forecast. What is the peak load is there? Because in some time maybe that peak can come. Now load is known to you. But like he said, we require the what kind of the resources are required. Their resources will be that some area is solar rich, some area is very windy rich. A lot of winds are there. Like we are in the village, so that will be a lot of biofuel will be there. or whenever you are using the renewable, so normally we will have the battery also. So what should be the each? Suppose we will take this area, this is my load, and we are simply have the AC, we have the solar, battery, we have the wind also, and some diesel unit. The reason for the diesel unit here is we try to reduce it, but whenever there is no solar is there, no wind is there, how you will get the power? In that case, you can have the power from the diesel. The next question here is, I know the load. So what should be the capacity of all other things? That is we call the planning, optimal planning. How much of the solar is required, how much of the wind is required, how much the battery, how much is the diesel. So that's why we are saying in the optimal planning of the renewable rich microgrid. Complete renewable we are not saying because we are using the diesel. So each of my generator will have, one is the installation cost, how much money is required to install that, and what is the operation and the maintenance cost. So what we are doing, we are writing the cost, say number of the solar unit plus installation cost plus operation and the maintenance cost. Similarly, we are going for the wind, we are going for the battery installation and the operation and the maintenance, we are going for the DG, and we are going for the converters. For each case, the different converters are required. And the last term, that we are putting the penalty on the carbon book. More the diesel we will use, more penalty you have to pay. And here we are just trying to minimize this. Minimize to find out what actually will be the optimal sizing of my each plant. So for the researcher, this is again a very big problem to solve this. You have to, you require a different technique. And here, once we are defining this, then we have to put the constraints. Say whatever be the we will select, my all resources will first of all fulfill the demand. Whatever is my electrical demand in that particular time, that must be fulfilled by my all the resources. Battery can be used as a source and can also be used as a load, depending upon the whether it is in the charging mode or in the discharging mode. So these both the modes we have to consider, and the diesel engine will have the capacity with my penalty. So with this, we have to basically run this optimization routine into objective is to find the size of each unit of solar, wind, battery, diesel, which can supply the load at a given time. So this is basically are the constraints, like we have given the battery is normally defined as a state of charge. If the battery state of charge is going below 30%, then this will be in the charging mode. Otherwise, this will be in the discharging. That curve will represent there. So as soon as this will come, sorry, 20 is taken. Whenever the battery, initially the backup is given by the battery. If the battery is going to be discharged below a particular limit, say the 20, then your diesel generator will be on. And diesel generator will be what? More penalty will be given. So our objective is to avoid the diesel generator, but whenever is required, we have to on it. So that basically give the total size of this, all the units which is required in this particular case. There the two approach are used. One is the genetic algorithm approach to solve this problem. Other is the F-min call. This is the algorithm which is used to solve the stochastic nature of the inputs. Because by solar and the wind, it is very difficult to predict. Although we estimate what will be there, but suddenly some cloud will come and this will drop. In the next moment again the cloud will be there. So you can see if the आपके पास एक plant है near about the 500 kilowatt, suddenly इसका ये drop कर गया 200 kilowatt पे, the next 5 minutes again it is coming to the 400 kilowatt. So this is called the volatile nature of the sources. So your wind and solar both are very volatile in nature. So this you also have to consider in your planning. Resolving. एक भी नहीं जा सकता. Want to continue or want to walk?
Continue.
हाँ, सुनना इनको पढ़वा. So these all are the basically regions which are generated by they have to click to वो कर दीजिए. So इसमें our in such studies, first of all we have to form a objective function, then make the analysis, select a algorithm by which you can solve this problem. And set your constraint according. So in setting the constraint, you have to take the minimum and the maximum limit both. Like in case of the DG generator, how the minimum it can generate and how maximum it can go. Or next is after the planning, then we have the control of the different control strategies which we have to use mainly to control the voltage and frequency. Say, the control technique normally which we will use in microgrid, that are the centralized, decentralized and the distributed. The first will show these are the centralized, this is the decentralized and this is your distributed. In centralized, which each individual machine or area will have its own control. Like we have the different DGs, either solar or wind or some other type or the battery. So they will have their own dedicated control. In decentralized, all these controllers are communicating with the some central system. And with this central system, all control action will be taken by this central control. In distributed control, we will have the communication between the each unit. Depending upon the status of the each unit, the decision is to be taken for any particular unit. The total microgrid control we normally divide in the three categories: primary, secondary, and tertiary control. In addition, here we have the level 0. Level 0 is totally we are going to the individual component. So that is not of very much of use here. But most important comes here the primary control, the level 1, which we are talking about. That is say this is a microgrid. In this microgrid, there are the number of devices are connected with this. If you will take this. So here we will have the individual control of the each element. Like we have the different sources. So there we will have the tubes. Group, anybody can explain? जानते सब है आप लोग. You already have known, but you have never seen. This is generator experiment performed here. This is generator. Which year? में क्या डीसी मशीन पड़ी है? जनरेटर पे लोड टेस्ट किया आपने कभी? बिल्कुल ठीक है. अब from voltage point of view, अभी हमने बोला कि if I will switch on the load, what will happen? The voltage will fall. जब हम जनरेटर को रन करते हैं, जबकि नो लोड पे, you will have a voltage. अब जैसे जैसे लोड बढ़ेगा तो क्या होगा? वोल्टेज कम होगा. This voltage will fall down. Is it fine? Voltage will fall down, speed will also fall down, falling down. So what will happen? In case of the synchronous generator, the speed is falling down, my frequency is also falling down. So just to supply one load, say at any moment the load is there. Suppose your generator have the capacity, say the 500 kilowatt. And 500 kilowatt at any time, maximum capacity, but any time say the 200 kilowatt it is supplied. No load voltage will be, let's say, is 230 volt. So your voltage will fall down, 232, let's say the 215 or 220. So at this moment, you will set up the frequency to the 50 hertz. Means you have to bring the speed up to that level so the frequency is 50 hertz. Means your prime mover is also supplying the 250 kilovolt. So that is my droop. We call it a droop characteristic. So this droop will appear in the voltage as well as in the frequency. So this might now from 250, it will become, let's say, the 300. So what will happen? In this line, you will fall down. So that is means you are coming down to that particular droop. So that droop control is my primary control. So what will happen? Once you will have the droop control, your naturally your load is increased, your voltage is fall down, your frequency is fall down. So whatever some phenomena or say the some action is there, which very slightly will compensate this. That is the property of your machine. But now you don't want this voltage to be at the lower value and the frequency to be fall down. So by this, again you have to recover this. How to recover it? By supplying the more electrical power. So that is called your secondary control. Giving your more real and the reactive power. So that will comes out to the under the category of your secondary control. The third control is in microgrid, you have the enough power. Your load, your generating power is more than the load power. What to do with the excess power? Now supply to the grid. So that is the tertiary control normally comes into picture whenever the grid is connected. If the excess power is there, that you have to supply to the grid. Normally, primary and the secondary control we utilize in islanded grid. So that's why here we are saying these are the three types of the control are there. So the converter side, if you will see, we have the three type of the converters. Again, the words are quite above your, you have not studied, but you will study in future. That your student can understand. Grid feeding converter is means the converter is giving power to the grid. And the type of converter normally how to feed power. What is the meaning of the feeding power? The excess power in the grid, I am feeding into the, in my system, I am feeding into the grid. So normally we use the current sources. At the each step, I am entering the current into this in place of the wood. Another is the grid forming converter. When I am isolated with the grid, now you require the voltage to be there. Initially, your voltage will be controlled by the grid. When you are in the islanded mode, now your inverters are deciding the voltage. So your inverter has to work in the grid forming mode. Or they are working in the voltage as a voltage source converter. So this is the current source inverter, voltage source converter. CSI and the VSI. These are the two forms of the converters, which you will study either in the third year or in the final year. In islanded mode, we normally use the grid forming. In grid connected mode, we will use the grid feeding and the grid supporting, operate in both grid connected as well as the islanded. So when it is grid connected, they work as a CSI. As they are the grid is off, they work as a BSI. So the three types of the converters are used. The primary, secondary control we already have studied.
We will do some.
This point I want. Maximum power point break. This is my solar panel. This is DC-DC converter. And this is given to the battery resistive load, battery and load. This is my MPPT controller which will control this DC-DC converter. Now what is there if my load is connected here? So this system has to operate at its maximum power. This is the voltage curve of the solar panel and this is the current. What is the power? Voltage is V, current is I, voltage is VI. So panel is supplying this. So what is the panel power curve? At each instant you have to multiply voltage in the current. So this is your power. So you at one particular voltage, your power is maximum. So this is the PI characteristic. So my objective to operate to draw the this voltage must be there to extract the maximum power from the solar panel. So that is my maximum power point track. So if I will use any voltage, so maybe I may be at this point or this point. My objective is to place my to draw the power up to this level, which will be the maximum power point tracking. That is my MPPT control. And most commonly, the another problem will come. If there are the partial shading, here the solar panel, the full sunlight is there. For the few panels, either the clouds are there or some shadow is falling on them. So like it is 25% shadow, 50% shadow, 100% light is in this panel will be. Then these characteristics will be of like this. So this partial shading further change your characteristics. Now in that case again you have to track the where you are getting the maximum power. So like in this case you are getting the maximum power at this point. So you have to develop your scheme in such a way that so this maximum power can be extracted from the panels. So again, this is the maximum. What we will do, I will don't go into the mathematical equation. So this is my MPPT control. This is the DC-DC control. You are getting a variable DC here. So what it will do at the different current value. This is called your P and O algorithm. Perturbed and observe. आप थोड़ा change करिए and see what is the power. Change करिए what is. If it is keep on increasing, you keep changing and increasing the power. Once it will reach to the peak, then your power keep on decreasing. So where it is reaching at the peak, you stop it there. So by this you will select. That is the P and O algorithm. this P&O algorithm will have the problem in such case. You keep on changing, it will reach there. Then what will happen? It will go, so it will stop here. So what it will search this peak. But this is not my peak. My peak is further there.
Please go back.
So in what we have to do, so some different technique again we have to use. So the different partial shading condition, what we do, we divide this whole region into the different, and how this is changing. There is a duty cycle. Duty cycle, you understand? Yes. Time to do your duty. Say, basically, we are using the switches. If your pulse is on, then the switch is in the closed loop. Otherwise, in the open loop. So, the duty cycle is how, in which time your switch is closed, and how long it is in the off condition. This on condition is called the duty cycle. So, in all power electronic control, we normally control this duty cycle. So basically what happening in the different time you are getting this different peak. So we already will have this stored. So we will divide the whole into the different sections. And for each section we will apply this P&O. Here, then here, then here. And we will see where it is maximum. This point is maximum, so we will select this particular point. So by this we will select this maximum power. MPP. So these are basically the work is done and the results are there. This is the algorithm. Those who are interested, they can go into this. So you can develop this using your microcontroller. How to control the modulation of your, how to generate this pulses for this DC-DC control. Duty cycle. Let us take one example for the voltage and the frequency. I'm talking about these two. As your real power is increasing, your frequency will fall down. This is called the droop. And here, as your reactive power will increase, your voltage will fall down. You are normally operating like, say, the F0 and V0. You are operating at this line. So whenever there is a change in the power, so this is the drop in the frequency, and this is the drop in the voltage. So in primary control, I have only this. So here in this approach, we are using this distributed control approach. And this is called the consensus algorithm, which is used to control this voltage and frequency. The Q is either the voltage, free or frequency, can be written by this equation. So QR1 means at the R plus 1 instant, I can write this equation and can use this KP and KI, the PID controller. So this is my system. Here we will have the 4 converters. They are connected to each other power with this RL element, and the load is connected at this point. So whenever there is at some base load they are working, whenever there is a change, there is a drop in the voltage and drop in the frequencies. And using this consensus algorithm, we are changing the firing angle of all the converters so that they can again retain to the same voltage and frequency. So initially we can see there is a active power sharing of the DGs, and that active power sharing is done by these groups. Before each converter we will have these groups. So depending upon the capacity, how much power each generator will have. Are the four converters who have the four group characteristic. So depending upon this, each generator will share the power. So that will give you the power sharing. And this is the reactive power sharing curve for all the generators. These are the voltage deviation due to the group control. Active power. Now here, due to this control now, we are restoring the frequency. Initially the frequency was dropped, and now using this secondary control, we can restore the frequency. And these are some supporting curve here. Voltage and the frequency both can be restored using the secondary control. So I think interlinking will be too high to them. So I will stop here. Here I will not discuss it. And basically this interlinking converter is for the hybrid microgrid. I just want to say here. And this is the part, this one is the part of the same project which we have visited. Design the development of the hybrid renewable microgrid with value chain application for agriculture. So the project we have visited, this is a part of this project. The three institutes are participating in this project: IIT Roorkee, Dayalbagh, and University of Prof. So this present discussion covers an overview of the microgrid architecture and control. This concludes the line. Want to discuss, which we have seen, otherwise so many people. Thank you. You can have